So welcome to today. It's us AFRY that is presenting for today to talk about AFRY in Malmö. So what do I think is important about us is that competence is really in our DNA. We have monthly competence groups. We have a journal circle where we go through papers or blogs each month. We also do knowledge share sessions. We have an internal blog, and we actually, even if we are a consultancy firm, we have actually sliced this time out of the client time, so you don't need to put it at the client and you're still paid, and you don't have to even talk to your client. So it's like we have managed all that already, so the time is there for you to use. We also do try to apply software engineering principles because we actually work in the software engineering team. We are just a virtual team which works with data at AFRY. So we do all review. You never work alone. You always work in pairs or more. And we also do have a lot of big data assignments, which might not be something each company has here in Malmö. It's not the biggest city, so to say. So yeah, and we are recruiting. We do need data engineer and data scientist and Scala big data. So if anyone is interested, please reach out. I think that's most of AFRY to talk about now. I don't want to go through the whole story. So this is what we heard for today, and the radar, of course. So we're going to talk about time series and what we have learned working with a lot of time series. So yeah, I think that's that. So who am I? I have a Master of Science in Computer Science. I did a Master in Machine Learning. I worked at AFRY later, or OF as it was when I began, at a client where I worked with geospatial data, big data, natural language processing, and all those parts on a lot of data. And then I became the team lead of analytics department where we work with data science types of things. I currently work with data-driven testing of 5G antennas. So when you produce the antenna, you want to make sure that the quality is high and that you don't let through bad antennas and that you don't block good antennas from making it through the production. So they want to look into all the test data. And we also work with forecasting bad behaviors in breaks. So I think this is recorded, but I did a previous presentation here which a little bit goes into this one, where I talked more about the data engineering parts of one project we work with and how you could profile code, how you could make your pipeline more efficient, and why it's good to be able to actually run code locally, because that's something people don't always do actually. So yeah, what are we going to do today? I'm going to introduce the assignments I just talked about a little bit more. Then I'm going to talk about embracing KISS principle and how interactive validation makes a lot of sense, and some other wisdom level ups we have had. So it's basically a mismatch of a lot of things we have learned and we have seen and tools we have applied, which we thought were good, bad. So it might become a lot, and we will put this down in a blog later, which I will share also. So you will be able to read up if it's too much. And if you're really interested in some part, please ask, and I will try to go further into that part instead of going through everything. So yeah, a minor introduction to the projects. As I said, the first part is a telecom company which produces 5G antennas, where we want to make the testing data-driven. Currently, they are looking at one measurement out of, it's everything from, I think, 60 times 12 times, yeah, I'm not sure. A few thousand data points, but they only look at one or two. So they want to look at more data. And the data is very unstable. We are talking about femtowatts, sometimes picowatts. And the end goal is to assist humans in analysis. So we're not going to try to automate some kind of behavior, but we're trying to help humans analyze the test data and thereby do better results. We also work in the automotive, where we forecast bad brake behaviors. So we want to understand brakes better. That's one part. So the other part is to actually forecast the bad behavior. So when does it happen? How far can we find this in the future? Like when can we see that the brake is gonna create some kind of weird kind of like this, that it's gonna go straight up. How far in the future can we do that? And the task was to actually validate a lot of different architecture and see which one works the best. They had previously applied both classical statistics and machine learning models like boosted trees to no greater success. So they wanted to look at neural networks, where we came in. So the first thing I am to present is embracing the KISS principle, which is keep it simple, stupid. Our first part where we actually failed on this is in our MLOps department, where we started out with actually a very solid tool called DVC or CML, where DVC is the data version control and CML is CI/CD for machine learning. The thing about this tool is that it's actually really, really good. So you have data version control. That's really good. You can actually control what kind of data you ran on. It's not just the pointer to a web address, but the actual data is hashed to keep track on so the data under the hood doesn't change. This means that we get reproducible pipelines. We also have CI/CD that is specialized for machine learning and deep learning, and it's cloud and tool agnostic, and it simply extends upon Git. If we look a little bit further into this, you can see like this is the concept of DVC. So you have a commit which tracks images. It tracks the I don't show it in this. Let's say that's the data set. That's the model and that's the metrics. Everything is contained in Git, and what they do basically is simply provide tools to make it easier to extract this out of the Git commit. So you get like special toolings. You can call like DVC metrics, and it will find the metrics file and extract that, and you can do diffs between different commits and different branches, and it creates a really good way of creating experimentation, and thereby you can branch like you do in normal software development, and then depending on which branch seems the best, you can deploy to production. Oh. But where we messed up is that we realized this is not really KISS principle. What we ended up doing was we created a lot of custom code to cover the DVC pipeline. We also found that each time we wanted to integrate a new feature, we had to somehow wrap this concept of DVC, which is not how you would do if you used an integrated way. And the communities was not as large as for other tooling. So what we in the end did, we bit the bullet and actually migrated to MLflow, which is the integrated way to do things. It's integrated in Azure, it's integrated in Amazon Web Services. So in our case, we found that actually the better, the better product actually wasn't the best product in our case. So simplicity over features. Because the complexity made it much harder to innovate and integrate new features into the system. So this is something like I just wanted to share a story where we like learned something pretty basic, but I think it's worth to think about. Sometimes the really good things end up being pretty complicated. So yeah, MLOps tooling. Some other thing we have decided to embrace is to always run a local first approach. So you can always run locally, which enables debugging in a much better sense. I talked a bit about this in the last presentation, so I think it would be good to go back into that if you're interested more about this. Also, I think something that I know other teams are not doing a lot is to automate boring checks. This is keeping things really simple because you forget things you need to do. You forget to do actual validation. So I don't know if everyone knows what a CI/CD is, but it's basically an automated way to run scripts and create validation on top of those scripts. So you should always create a CI/CD pipeline, which is really simple today with today's tool, and I also recommend using pre-commit. Yeah. Also, some other one really stupid thing we did, which was really cool, was we started like in one project where we had a very small data set. We started typing the data set with enums, which means that you get typed Python code, which is really cool. But in the end, it ended up being pretty complicated because you have to unwrap the enums all the time. And that annoyed the heck out of everyone, I think. So I think like the way to keep track of columns is basically just never define them. Just use input output. So you define them at the start of the flow and the end of the flow, never touching them. Also, yeah, I think that's most. So to the third point of interactive validation, why and hows. So static results is the de facto how you validate machine learning pipelines and data science projects. So you have metrics, you have some static graphs, but it's not really enough, especially when it comes to time series, because in time series, like mean squared error, it's really hard to define what does it actually mean. Do we have like a lagging graph which actually has pretty good performance, but it's just copying the value previously? And that's also pretty hard to see when you have a static graph. And another thing about validating with those two classical metrics is that it doesn't actually promote exploration and diving into the data deeper. You might end up starting to experiment without actually viewing the data again, and you get used to your pipeline. And we're into data, right? So we should dive into the data, which is something we have found very refreshing and very appreciated by the end clients, because finally they can use the models and actually look at what do we produce and what does it happen. So interactive results, it's a bit more time consuming. I will show you later how one example how you could do it. It promotes exploration and comparison because you actually use the models actively, looking at the data. How does this model behave? How does this model behave? And if we slide on the time series, how do they behave in different kinds of scenarios? This is really hard to capture inside a metric like MSE. It's also hard to capture in static images, because how can you know where to pull this static image from when you have a dynamic test valid and train split ratio? Yeah, and it also expands outside what we can expect, I believe. We have found that actually interactively looking at our results, we have realized so much about what we can do that the starting project didn't actually like with the 5G antennas. We have created so much more. By being able to this, we have found other tasks to solve, other things to do. It's also, in my opinion, maybe this is a bit wrong, but it does increase model understanding, especially if the end user gets a bigger understanding, they believe. And it makes the feedback loop much more efficient. And as someone said the other day, it's very satisfying to see, seeing the model keep on predicting and gaining it back. So yeah, I just wanted to show a slide. So this is like a basic metrics chart, static. You might have some images of the time series too, but as I said, it's hard to see like how, if you have a lag, if it's applied all the time, do you do really good in some places but really bad in some places, and the magnitude is very off. Then an interactive approach like this is not actually our tool because I can't share it unfortunately, but I found something similar. So this is essentially how you could do one such thing. Of you get the prediction, you can work with the prediction, you can change the kind of time scale, you can also change like parameters, you could change the file you're viewing. You could also have like this kind of table at the bottom where you could swap models dynamically. You could compare models. I think you can imagine the kind of possibilities for this. And this is something we have found great success with. And also showing it to the end users, like the ones who wants to actually consume the model. They do really enjoy this kind of interactivity and working with their models. Some other wisdom level ups we've done. which I do enjoy. One thing is a paper we found recently about making forecasting probabilistic, which means that instead of giving one value, you get a range of values, which is not something common neural networks actually do because they produce one value. There is no real uncertainty. But there was a simple yet expressive idea of let's run inference, but we do applied dropout. Dropout means that we randomly drop data points, which is what we do during training to make the model more generalized and more robust. So we do run a lot of predictions with dropout activated, and then we build a confidence interval out of this. Very simple but efficient. It was a paper from Uber, which means that you, rather than getting like the green graph, you actually get like, and you can see like right here, the model is actually very certain about where it should go. But right here, it's a very big gap. So we can see where does the model not behave as expected, where is it weak, and can we somehow try to impact this. This is also something you can integrate into the interactive tooling to be able to look at different plots in a simpler way, gaining some really fast feedback loops, which is awesome. You always want the feedback to come quick. We have also learned some things about using custom loss functions to simplify the problem for the model so it can converge faster. So some of these are basic, but you shouldn't use the same validation metric as the loss function. You optimize the validation metric and thereby you get very biased. And it's very hard to actually measure, did we progress? You should also, of course, decide on a validation metric when you start and don't keep it a moving target because, even if you do keep track of all your experiments, if you don't measure the same metric and keep that as your core metric, you don't know where you moved. And also, you should always think about what actually matters in the end. So you can, even if you decide on a validation metric in the start, you can add more metrics as you go, which aren't the core metric. But sometimes you find, we really only care about how we forecast in this special situation, which is for us when the break misbehave. We don't really care how we forecast when the breaks are as they should be. That's not a problem. And how do you do that? And that also helps to actually validate, because the custom loss function in our case was to be better at forecasting break misbehavior. So then we need somehow to actually measure, did we actually improve that? Because misbehavior is a very small part. Some other general issues we found. We trusted papers and open source libraries too much. We found that in a few places, actually, the weight instantiation was very badly done. So this is something to keep track of. The models couldn't converge, especially when the network grew too wide or too deep. It's something I didn't expect, but I've seen now. We also found that sometimes best practices are not the best practices in your use case because it might be smaller and some other company might have like a huge pipeline while yours is very small. Or you have a huge pipeline and you're looking at someone who worked with very small. You should always think about what is your situation. Is it very close to the other situation or not? And also, it's very hard to visualize data in the right way. And I think the only way to actually do this really good is to have a tight end-user feedback loop. So we actually visualize what we care about. And some general winning concepts for us this far in our team is to add type hints everywhere. Also, we have found great success using Plotly and Altair rather than Matplotlib. Coming back to the interactivity, I just wanted to showcase one graph we did in our team. Actually, Gaston here, where you can see this is something you can take a graph which you could have in Matplotlib, but taking so much further by actually adding all this kind of interaction where you can move on the time domain and on the how fast it's sampled. How many measure points per second domain, and you can combine these. This is something, like you could have the raw graphs in Matplotlib, but adding this interactivity makes a lot of difference to actually understand what is happening in the data. One other thing is we found adding polars helps a lot with speed. We use Streamlit a lot to make our interactive apps. It's a very easy way to create an interactive app which also has caching, which makes it very, very fast, because everything that's expensive you reuse rather than recompute. There is other tools, but I recommend using some simple tool as this one, or Gradio maybe. Also, as I said previously, CI/CD. So you push your code, you run the integration tests, then we have a code review, you loop back, and then make sure that everything happens and we don't introduce any bad behaviors. Another thing we learned, which I don't know how many knows, but if you ever heard about Quarto, it's something really, really cool I want to share, which has helped us creating reports for our clients whenever we do a report. So Quarto is a way to either use notebooks, Jupyter, or using what they call Quarto Markdown, which is basically like take everything you like about LaTeX, put it into Markdown, and introduce code cells. And then you can actually produce websites which are interactive. So if you have an interactive plot, you have an interactive plot in the website. If you produce a PDF, of course it can't be interactive on a PDF. It's a fixed format. What I also realized today when I actually snipped this screenshot from them is that I could have made this presentation in Quarto. Too bad I didn't. So yeah, what have we learned? If I summarize very briefly: follow, keep it simple. Also embrace the systems you're working in. So don't introduce like an MLOps platform that's not integrated if there exists an integrated way to do it, because if you generalize too much, like we were thinking like maybe we shouldn't take a tool that's locked into Azure in our case, but when will we leave Azure? And whenever we leave Azure, we will have to add all the authentication and all that, so you might rip off the band-aid when you come there, and just embrace it to save a lot of time and work. Interactive analysis are incredible, and it opens so many doors. I really, really recommend it. And then always be mindful. Continuously evaluate what you do. Keep track of the whole pipeline. Don't only look at the start and end. Also look in the middle. I think that's all. And once again, yeah, we will have an AFRY AI Summit where we'll talk about UX design in combination with AI. We have a professor who works part-time on university with this and part-time at AFRY. And then we'll also talk about some other things. So it will be really interesting if you're interested. Not that technical, more light, but yeah. Any questions? Oh. Maybe that was stupid. Yes.
Hello. I have a question about DVC.
Yes.
How does it work with? With Git, it's diffing on like line breaks. But how does that kind of work when you can have all different formats of data? I guess, can it handle things from CSV to?
Yes, it does.
For
Yeah.
example.
So.
And does it work well with these?
When we started using it a while back, it did not have line validation. It was dataset validation. And the dataset is no problem because it's just a simple hash out of all files.
And if the dataset changes,
then the hash changes, yes.
Okay, so there's no like incremental.
No, exactly. So no, it will only validate that you have the same data set, yes, or not. But it will also validate other things, like it has some kind of innate experience, like it knows about CSVs, so it will know how many lines there are, it will know what file sizes and like those kinds of metadata. But Parquet, I don't think they had support to like know how many lines a Parquet file was. But I think it doesn't really matter that much, because you only want to know that you're using the exact same data set to create the exact same model and the exact same code, so you get the reproducibility.
Okay.
Yeah.
Thanks.
No worries.
So, what this tool there, which built on Git, what exactly did it do more than Git?
A lot more. Like I said, it's I like how everyone's is stuck with the tool we scrapped. I think it's a really great tool, but I think if you're gonna go all in on this, you need to go all in on the company-wide level, like, yeah, because it's a lot of work to create the pipelines in it, even if they're really good. So basically, you can't commit a large data set in Git. You have large file storage in Git, but if it's really big, it's really bad. It's really slow too. So what they do is they keep the reference, they keep the hash, they keep a lot of other metadata, but they keep metadata and the hash makes sure that it's the same data set. It's like when you download a program that you want to run, you can check the MD5 checksum. So this is the same set, but for a data set. And then a lot of metadata about where it came from. So it doesn't actually commit the data set, and you can't do that in Git unless you do write all this by hand. And then, yeah, why use the tool if you are going to write everything by hand? It also supports, yes, you commit the images, you commit the metrics in Git, but what they do is they allow you to do like DVC metrics diff, and you get a table with the diff, visually pleasing. You can also do plot difference and show the difference between different plots. So you might have the validation, the F1 score as you train by each epoch, and you might have 3 models. Then you can show all 3 models at once in the tool directly from the commits. And it also adds a lot more, like how to download the dataset from Azure if that's your blob storage, or Amazon and Google. So it adds those kind of connectors. What we found though is that the Azure DVC has to use the HTTP API requests, and it took, I think, 1 hour to download the dataset. And if you use Azure CLI, which I'm not sure if it's a WebSocket or what, but then it took 10 minutes. So some kind of artificial blocker. But it does have those kind of it's a lot of help. And also they because you build pipelines in it, it allows for experimentation. So you can run an experimentation, and when you like an experiment, you can create a commit out of it. So yeah, it allows you to compare all those experiments and branches, commits, all those concepts. I don't have a lot more to say, but it expands on Git, but it uses Git purely. So it's really beautiful in that way.
Hi, just continuing this train of thought. Did you feel like you missed anything once you moved to MLflow, or
especially the data version control? That doesn't exist in MLflow. The only thing MLflow can actually validate is that you're pointing to the same data. And if you have a local data set, I don't think it might even be able to do that unless it's an input parameter. But in our case, we use, when we do train on a cluster, we train through Azure in this project. And then in the MLflow metadata, it will point to an Azure dataset. And that Azure dataset in turn can be versioned. But it's not because of MLflow. But in DVC, you actually had that. Also, I think yeah, I don't know, but there was so much gains by actually taking MLflow because Azure supports MLflow by default, and because of that, it's there is a lot of magic happening.